This video will review the Unit 2 written activity, pages 4 through 5. Question 11. The TCA cycle starts when acetyl-CoA combines with oxaloacetate, OAA, to form citrate, isocitrate, alpha-ketoglutarate, succinyl-CoA, succinate, fumarate, malate, then OAA again. NADH is released 3 times and FADH2 once per turn of the TCA cycle. Question 12. In the electron transport chain, complex 1, called NADH dehydrogenase, accepts electrons from NADH to pump protons from the matrix to the intermembrane space. The electrons are shuttled to ubiquinone, UQ, then to complex 3, cytochrome BC1 complex. This complex also pumps protons to the intermembrane space. Electrons are then transferred to the mobile carrier, cytochrome C, over to complex 4, cytochrome C oxidase. This complex transfers the used electrons to oxygen, which reduce with protons to form water. Complex 2 can add electrons to the system too, but from FADH2. Complex 2 does not directly pump protons, but its electrons can power complexes 3 and 4 to moderately contribute to the proton gradient. Question 13. Recall that substrate-level phosphorylation is a type of direct transfer of a phosphate group. So the only 2 stages where ATP is directly made is during glycolysis and the TCA cycle. A major purpose of these steps is to acquire the reduced coenzymes NADH and FADH2. Glycolysis releases 2 NADH, the intermediate step 2 NADH, and the TCA cycle 6 NADH and 2 FADH2. These reduced coenzymes can be used to power the electron transport chain. For every NADH used, about 3 molecules of ATP can be made, whereas FADH2 can be used to make about 2 molecules of ATP. So, for glycolysis, the 2 NADH can yield 6 ATP molecules at the end of the electron transport chain by oxidative phosphorylation. The intermediate step can produce the same amount of 6 ATP from its 2 NADH. The TCA cycle is the most fruitful, as is 6 NADH can yield 18 ATP, and its 2 FADH2 can yield 4 ATP. To sum these together, glycolysis makes 2 ATP by substrate level and 6 by oxidative phosphorylation, for a total of 8. The intermediate step produces only 6 ATP molecules by oxidative phosphorylation. The TCA cycle directly makes 2 ATP by substrate level and 22 by oxidative phosphorylation, for a total of 24 ATP. Summed together, 8 plus 6 plus 24 is a total of 38 molecules of ATP by substrate and oxidative phosphorylation, following the complete oxidation of a single molecule of glucose. A chloroplast has 3 sets of membranes. The outer is much more porous than the inner membrane. Within the liquid stroma is another suspended set of thylakoid membranes, which are stacked into multiple grana. The thylakoid membranes are the sites of the light-dependent reactions of photosynthesis.